Hello everyone, welcome to solution of next assignment on numerical methods and computer programming. The first numerical which is given to you, apply Descartes' rule of sign in x raised to 4 plus 2x cube plus 10x minus 20 is equal to 0 and determine possible number of positive real root, negative real roots and complex roots from this. We have to determine the numbers only, not the root. Okay, so how many positive roots is for this equation, how many negative roots and how many complex roots are for the equation. Total number of, how many total number of root of the equation, total number of root of the equation is always equal to the order of equation, that is n is equal to 4, that is the highest order of this equation. The given function is x raised to 4 plus 2x cube plus 10x minus 20. So how many sign changes are in this equation? Here plus to plus, no sign change, plus to plus, no sign change, plus to minus, one sign change. So number of real positive roots is always less than or equal to number of sign changes in f of x. So the possible number of positive roots for this equation is always less than 1 or less than 1. Maximum one positive possible root for this equation. Then we will determine what is f of minus x. So x is replaced with the minus x raised to 4 plus 2 minus x cube plus minus 10x minus 20. So minus x raised to 4 will be x raised to 4, minus x cube will change the sign, minus 2x cube. 10 minus x will give you minus 10x minus 20. So how many sign changes are in f of minus x? Plus to minus, one sign change, minus to minus, no sign change, minus to minus, no sign change. That is, there is only one sign from plus to minus. Hence number of negative this is not a positive, this is a number of negative roots. Sorry, by mistake it is written as a positive, it is a number of negative root. While reading this, please read that is a number of negative root. Number of negative roots are the number of sign changes less than or equal to number of sign changes in f of x, that is q is less than or equal to minus 1. So how many complex roots are there? Obviously total number of roots are 4, maximum possible positive root are 1, maximum possible negative root is 1. Hence total number of complex root is number of roots minus number of possible positive root plus number of possible negative roots. So 4 minus p, 4 minus 1 plus 1, that it gives the number of complex roots for these equations are 2. Okay, let's solve the next example which is based on this numerical method. Here we have to use the synthetic division for the calculation to find the root of polynomial equation, that is use of Brige-Vieta method. So using the Brige-Vieta method we have to find out the root of this equation which is near to the 1.5. Initial value is given as a 1.5. So what is the power of equation? 6. So but the fifth x raised to 5 term is absent, then x square term is absent, x term is absent. So I will rewrite this equation with all power of x, starting with the highest power, x raised to 6, 0x raised to 5, but this was absent here, so I'm writing it as a 0, minus x raised to 4 minus x cube plus 0x square plus 0x minus 1. Now I will write down the coefficient in the first row. See that these coefficients are written here. What are the coefficients? 1, 0, minus 1, minus 1, 0, 0, minus 1. Starting from the highest order to the lowest order, we write down the coefficient first. And what is the initial value given? In the first iteration, the initial values are given as 1.5. And what is the order of equation? N is equal to 6. Order of equation is 6. So initial value is 1.5. So first write down the 0 on the first coefficient and add these two. So 1 plus 0 gives you 1. Then multiply 1.5 with this one and write down here. So 1.5 into 1 gives you 1.5. 0 plus 1.5 gives you 1.5. 1.5 multiplied by 1.5 gives you 2.25. Minus 1 plus 2.25, minus 1 plus 2.25 is nothing but 1.25. Again 1.5 multiplied with 1.25, write down here 1.875. This 1.875 is the multiplication of 1.5 and 1.25. Then add this minus 1, 1.875. Likewise you continue this process up to last coefficient. Okay, after the last coefficient, again come back, again this one, write down the 0 under this or carry this one as it is here, then 1.5 multiplied by 1, 1.5, 1.5 plus 1.5, 3. We have to perform the synthetic division twice. 1.5 to 3, 1.5 into 3 gives you the 4.5. Okay, 4.5 plus 1.25, 5.75. This should be continued up to second last column. Second last column. Do not go for the last column. What is the Brige-Vieta formula? New root is equal to old root plus bn divided by cn minus 1. This is your row A, this is your row B, and this is your row C. So row B, the Bn, what is the n? N is equal to 6, that is a B6 divided by Cn minus 1, that is a C5. So B6, B0, B1, B2, B3, B4, B5, B6, and Cn minus 1, that is n is 6, so C5. 0, 1, 2, 3, 4, 5. So 1.5 plus 1.953125 divided by 25.3125. It gives you 1.5772. So see that initial value was 1.5. Now the new value is new value of the root, approximate root is 1.5772. For the iteration 2, take the last answer as the answer as the initial value in the next iteration. That is, I am taking 1.15772. The procedure is same as in iteration 1, only this 1.5 is replaced with 1.5772, that is updated root. Now perform the synthetic division using this root, that is 1 is carried here, 1 multiply with 1.5772 is written here, 0 plus this is written here. Likewise again perform the synthetic division. Again new root is equal to old root bn divided by cn minus 1, that is old root is p0 plus b6 c5. So what is the p0 for iteration number 2? It is 1.5772 plus this is added, it gives you 1.6983. okay, for the next iteration you take the p0 is equal to 1.6983. so sorry, here it is 1.577 is written. Okay, here 1.577 is written. This should not be 1.577. This should not be 1.577. Okay, what it should be written here? We should write here this value is equal to 1.6. Sorry. What value should we write here? This value should be 1.6983. So 1.6983 or 81, whatever that value, 81, sorry, 1.6981. Taking that value as the initial value, we will calculate the next root. Again the same procedure, but initial value is this one. Again calculate this. So this is the Brige-Vieta method for the calculation up to third iteration. If you continues goes on iteration, at the sixth or seventh iteration you will get the exact root. When this root starts repeating, you can stop there. Okay, here only 3 iterations are asked. The next numerical is it is depending upon the calculation of error. In a measurement of voltage and current in experiment, measured values are 299 volt and 10.1 ampere respectively, and accurate measurement is 230 volt and 10 ampere. Accurate is 230 but measured is 299, and accurate value is 10 ampere but measured value is 10.1 ampere. Calculate the absolute and relative error in each case and compare the results. So let's see the voltage measurement. What is the true value? True value is 230, and what is the approximate value, that is measured value? 229. So how will you calculate absolute error? Absolute error is always mod of true value minus approximate value. True value is 230, approximate value is minus 229. So absolute error is equal to 1 volt. How will you calculate the relative error? Relative error is equal to mod of true value minus approximate value upon mod of true value. So that is 230 minus 239 divided by 230. That is absolute error divided by true value. 230 minus 239 divided by 230 into 100. So it comes to 0.4348. So see, the relative error has a unit, but absolute error has a unit, that is equal to the measurement quantity, but relative error is not unit, error is in percentage. Similarly, we will calculate the true value in the similarly we will calculate the absolute error in current measurement. True value minus approximate value, 10 minus 10.1, it gives you 0.1 ampere. Relative error is 10 minus 10.1, it gives you minus 0.1, but it is a mod. So minus 0.1 divided by 10, it gives error is 1%. See that here error is 0.4348, here it is error is 1%. Now we will see the observation. In both cases, absolute error and relative error is calculated. In voltage measurement, if you see in the voltage measurement, absolute error is 1 volt and 1, and here it is a 0.1. It indicate that absolute error in the voltage measurement is greater than the current measurement, but absolute error is not unitless quantity. Absolute error, how this unit is a volt, this unit is ampere. In voltage measurement, relative error is less as compared to the um, error in current measurement, but relative error is unitless quantity. Relative error is don't have a unit, both are in percentage. So what is the conclusion? Though absolute error in the measurement of voltage is larger as compared to the current measurement, it cannot be comparable because it is not a unitless quantity. So two different measuring system can be compared on the basis of relative error. In this case, the error in the current measurement is greater than the voltage measurement. Here look like absolute error is less, but the relative error is larger, so that current measurement is less accurate as compared to the voltage measurement. Thank you.